Okay, this video goes over section 8.5, which is going to look at absolute value equations and inequalities. Absolute value is the distance from zero, so it's always positive. You can solve it to find out what goes in the absolute value. So the basic premise is whatever you put inside comes out positive. So if we put a positive 20 inside that, the square root of, or the absolute value of 20 is 20. We can also put a negative. The absolute value of negative 20 is 20. So when you're taking absolute values, there's always two answers. Now that also helps you think about this. If absolute value is always positive, you can't get a negative, so there would be no solution if it equals a negative number. And then the last point to think about is 0 isn't positive or negative, there's just the 1, so there's only one answer when it's 0. All right, graphing absolute value. We're gonna do one by hand, and then I'll show you how to do it in the calculator. So here's a graph. Then I gave you a bunch of x values to plug in. So if I were to do the first one, 3 times negative 3 is negative 9. Negative 9 plus 3 is negative 6. And the absolute value of negative 6 is 6. So that point is at negative 3, 6. Now let's do it again with negative 2. 3 times negative 2 is negative 6. Negative 6 plus 3 is negative 3. And the absolute value of negative 3 is 3. So I can graph negative 2 comma 3. Do it again with 1. 3 times 1 is 3. Negative 1 is negative 3. And then negative 3 plus negative 3 is 0. Absolute value of 0 is 0. So we have a point, negative 1, 0. Do it again with 0. 3 plus 0 is 0. 0 plus 3 is 3. Absolute value of 3 is 3. So we go 0, 3. Do it with positive 1. 3 times 1 is 3. 3 plus 3 is 6. Absolute value of 6 is 6. So we have a point at 1, 6. Do it with positive 2. 3 times 2 is 6. 6 plus 3 is 9. Absolute value of 9 is 9. So we have a point at 2 comma 9. And then 3 times 3 is 9. 9 plus 3 is 12. Absolute value of 12 is 12. So we have a point at 3 comma 12. Then if I were to trace those lines, we have our absolute value graph, which is a V. We can do the same thing on our graphing calculator. To enter an absolute value graph on your graphing calculator, first you're going to go into the y equals menu, which is that top left button. Then to get the absolute value, you're going to hit math, which is right below the green alpha button, arrow over to num, and choose number 1, which is abs, or absolute value. It puts the bars there. Then we can type 3x plus 3 right in there. And if we click zoom, top middle, and then 6 for the standard, it will show our graph, and it'll look very similar to the one we drew. All right, now let's talk about solving them. So like we said before, whatever you put inside can be negative or positive. So we're going to take the equation exactly as is and say it equals the positive answer. And then we're going to do the same thing and say that it could be negative 3 because the absolute value would end up making it positive. Then we just solve both of these. So we add 5 to both sides. 2x equals 8. Divide by 2, we get x equals 4. Same thing over here. Add 5 to both sides. 2x equals 2. Divide by 2, and we get x equals 1. So we have both of those answers. Just to show you, if we plugged it in, 2 times 4 is 8. Minus 5 is 3. Absolute value of 3 is 3. 2 times 1 is 2. Minus 5 is negative 3. And the absolute value of negative 3 is 3. So they both work. So you're looking to get two answers. This one here, we want to move the 2 so that the absolute value is all alone before we do the positive and the negative. Now that all we have on the left is absolute value, we can do 5 minus x equals positive 10, and 5 minus x equals negative 10. Then we just solve those. So I subtract 5 from both sides, divide by negative 1 to get the x positive, and we have negative 5. Subtract the 5 from both sides here, we get negative x equals negative 15. Divide by negative 1 to make the x positive, and our two answers are 15 and negative 5. Now, if we look at this one, there is a fraction, but it's inside the absolute value. Absolute value is fine. It's all alone on that side. So we're going to take exactly what's written in there and make it equal positive 3/4 and negative 3/4. Then I'm going to distribute my fraction. Half of 6 is 3. It's going to be the same on both. Negative 3/4. Now, if I want to get rid of the fraction, I can multiply everything by 4, the least common denominator. 4 times a half is 2. 4 times 3 is 12. And 4 times 3 is 12, divided by 4 is 3. If I did the same thing over here, 4 times a half is 2. 4 times negative 3 is negative 12. And this would end up being negative 3. Now I can solve by bringing the 12 over. So we get 2x equals 15. Divide both sides by 2, and I get x equals 15 over 2. Same thing over here. I'm going to add 12 to both sides, so I get 2x equals 9. Divide by 2, and we get x equals 9 over 2. So those would be the two answers for this problem. Now let's look at this first one. Absolute value of 2x minus 1 equals negative 2. Now I know over here I said you're going to find a positive and a negative, but we get rid of the absolute value when we do that. Here we're trying to say that the number that comes out of the absolute value is negative. Well, that's not possible because absolute value has to be positive, so there's no solution. Another thing you might see is if it equals 0, like we said on the front page, we only have to do one. There's only one thing that it can equal because there isn't a positive and a negative 0. And then we just solve that like normal. So subtract 4 from both sides, divide by negative 2, and we get x equals 2. So when it equals 0, we're just only getting one solution instead of 2. Now this one looks like it might be scary because there's two absolute values. Not scary. We're going to do the same thing. We're going to take the left-hand side, and we're going to make it equal whatever the right-hand side is, but positive. So leave it just like that. Then we're going to do the same thing. Left-hand side, and we're going to make it equal the right-hand side, but negative. So just stick a negative in front of it. Then we're going to need to distribute that negative sign. And then we can move, then we can move the x over here. So we would get 3x equals 3. Divide both sides by 3, and I get x equals 1. On the original one, I'd subtract x from both sides, and I would get x equals negative 3. All right, so you try the next, so the next couple, they're the same. It's the same idea. It has an inequality sign, but we're going to start by solving it the same way. We're going to say 2x minus 1 equals 3, and 2x minus 1 equals negative 3. Add 1 to both sides, divide by 2, and I get x equals 2. Same thing over here. Add 1 to both sides, divide by 2, and we get x equals negative 1. So far this is the same. Now we have to decide where our graph is. So remember, our graph's a V of some sort, and we want to know when it's less than 3. So if the graph went up, we would want to know these 2 points would be the part here where it's between, and we want to know if it's less than in these pieces or the other piece, because the graph could also go like this. So we're going to do a test point. Pick a point somewhere between -1 and 2. Now, if I have a negative and a positive, I always choose 0 because it's the easiest to plug in. 2 times 0 is 0, minus 1. -1, the absolute value is 1. 1 is less than 3. That's true. So that means between the 2 points is less than 3. So our interval is just going to be from -1 to 2. That's all. So if your test point is true, you have one interval. Now let's do this one. So we're going to solve 2 minus 3x equals 4. Subtract 2. Divide by negative 3. X equals negative 2/3. And then we do it over here with the negative 4. Subtract 2. Negative 3x equals negative 6. Divide by negative 3, and x equals 2. Let's test 0 again. If I plug 0 in, is 2 greater than 4? No. So since our test point doesn't work, that means we're talking about these pieces, the two pieces outside of our test points. So we write that as two intervals. Negative infinity to the smaller point, and then the bigger point to infinity. That's how we get our two parentheses. So I would recommend pausing the video and trying these two and checking in and seeing how you do. All right, so here we have 2x minus 5 over 3 equals 3, and 2x minus 5 over 3 equals negative 3. Multiply both sides by 3 to get rid of that fraction. 2x minus 5 equals 9. Add 5 to both sides, so 2x equals 14. Divide by 2, we get x equals 7 for 1. Over here, we're going to multiply both sides by 3. So we get 2x minus 5 equals negative 9. Add 5 to both sides, we get 2x equals negative 4. Divide by 2, we get x equals negative 2. Meaning I can check 0 again, because 0 is between negative 2 and 7. So if I plug 0 in here, I'd get negative 5/3, and the absolute value of negative 5/3 is positive 5/3, which is not, in fact, greater than 3. So since it's not true, we're going to write the two brackets. So negative infinity to negative 2, and 7 to infinity. And again, I choose which one goes which based on the smaller one on the left, the bigger one on the right. All right, let's do this one. 4 plus x equals 5. 4 plus x equals negative 5. Subtract 4, we get x equals 1. Subtract 4, we get x equals negative 9. If I plug 0 in, 4 is less than 5. That's true. So our answer is just going to be between negative 9 and 1. Remember, smallest to largest. All right, here's two more for you to try. Pause the video, try them out, see how you do. 4 minus 5x equals 3, and 4 minus 5x equals negative 3. Subtract 4, negative 5x equals negative 1. Divide by negative 5, we get x equals 1/5. Sorry, subtract 4 over here, we get negative 7. Divide by negative 5, we get 7/5. So this time they're both positive, so we can't use 0. But 5/5, which also equals 1, is in between those, so we can try plugging in 1. Well, 4 minus 5 is negative 1, and the absolute value of negative 1 is 1. 1 is less than or equal to 3, so it's between the 2 points. So we're going to do the same thing we've been doing, where we write the 2 points. But because of this less than or equal to, we're going to make these brackets instead of parentheses. It's the only difference if you have a less than or equal to. All right, let's do this one. Negative 4x minus 6 equals 2. Negative 4x minus 6 equals negative 2. I'm going to add 6. I'm going to divide by negative 4, and I get negative 2. I'm going to add 6 and divide by negative 4, and I get negative 1. And these are both negative, and they're really close, so I'm going to have to plug in 1.5. So negative 4 times negative 1.5 is 6, and 6 minus 6 is 0. And the absolute value of 0 is 0. 0 is not greater than 2, so we have to write our dual. So negative infinity to negative 2, and negative 1 to infinity is how that part would fit. All right, let's look at a word problem. An engineer is designing a circular cover for a container. The diameter of the cover is to be 4.25 inches and must be accurate within 0.01 inches. Write an absolute value inequality. So what we're saying is if the diameter of the one we make and we subtract the 4.25 that we want, we need that number to be within 1.1. So it could be like 4.26, could be 4.24, anywhere within that range. So really, we're saying we want it to be less than or equal to 0.01. And if we do the absolute value, that accounts for the plus and the minus. That's all that means when it says to write it. The value you're looking for minus what you want should be less than or equal to the accuracy. All right, let's look at this one. The inequality T minus 50 is less than or equal to 22. Models the range for monthly average temperatures in Boston. Solve and interpret. Well, if we solved, we would do positive 22, where we add 50 to both sides, so we would get T equals 72. And if we did negative 22 and add 50 to both sides, we get T equals 28. So the interpretation is the average temperature in Boston falls between 28 and 72 degrees. If we wanted to graph that, we could go to our y equals, math over to num for absolute value, and do x minus 50. Then for our 22, if we put that in the other line, we can look and see where they intersect. So let's see what happens if we zoom 6. So we see this graph here, and we know we only are worried about the temperatures from 28 to 72. So I could change my x min to 28 and my x max to 72. Let's just do 0 and 100. And sometimes the windows play, you got to play around for a little bit to get what you're looking for. And then our y, we know we want it to get to 22. So let's try 30 and just see what we get. Sorry about that. So now if we look, we have the points where they intersect. Those are the 28 and the 72. Those are where they intersect. So the temperature is this red part here. That's when it's less than 22. All right, let's look at 2 more. These are special ones again. Now, this has a negative. So if it was an equal sign, we'd say no solution. But here, it's a greater than sign. Well, if everything that's absolute value comes out positive, positive is always going to be greater than a negative, so you can put anything in. You can have any solution. So that would be negative infinity to infinity, all real numbers. You could call it identity. All of those things work to tell you that anything will be there. This one, we're going to subtract 3 from both sides to get our absolute value alone. And now we have a negative again. But this time, our symbol is less than. Well, we don't want to be more negative, so we can't have any solution. That's how those work. So that is the rest of section 8.5. Let me know if you have any questions.